Notice that I haven't even talked about the right-hand side yet, because all I'm doing is I'm thinking about the pre-processing of the matrix A. So I'm not actually analyzing the linear system. I'm taking A out of the linear system and analyzing that. The thing I want to start targeting is I want to really start focusing on what's happening there. So I want to make a note here, and then we're going to do a conjecture. So let's go ahead and look at S 3, 1 of negative 1 times S 2, 1 of negative 1. And there's kind of two ways to do this. There's the brute force way to do it, which is actually quite painful in everything but the 3 by 3 case. And I encourage anybody that wants to do the brute force, beat me to this, OK? But then there's the way to do it by definition, right? What is S3, 1 of negative 1? Yeah, so you have the identity matrix. And let's just do it in IN, shall we? We could do it in I3. It doesn't really matter. You have the identity matrix plus negative 1, E3, E1 transpose, identity matrix plus negative 1, E2, E1 transpose. When you have, you remember this thing? This is a matrix multiplication. That thing is an addition. What do? Distribute. I don't know if you want to distribute the left one over the right or the right one over the left. Do you have a preference?
Left to right.
You want to distribute this one over that one. Awesome. So what happens when I multiply this entire sum by the identity matrix? What happens when I multiply anything by the identity matrix? Awesome. So I don't have to do any work. It's one of my favorite. Well, I guess if it was 0, that's actually my real favorite one, right? Because then I don't have to write anything. OK, now what? When I multiply this by that, so now I get a plus the entire thing here, E1 transpose, and then now I have a negative 1 E2 E1 transpose. OK, so now I have I3 plus negative 1 E3 E1 transpose. What's happening here? So first we distributed the left one over the right sum. Now we're going to distribute the right one over the left sum. When I multiply the identity matrix by this thing, what happens? Stays the same. So now I've got negative 1 E2 E1 transpose. And then what about here? This is a 3 by 3. This is a 3 by 1. This is a 1 by 3. So that matrix right there is a 3 by 3. That matrix right there is a 3 by 3. You've got an outer product times an outer product, right? OK. What's this thing? Yeah, we could just write it down. So this is going to be a negative 1 E3 E1 transpose. Anybody see how much privilege is involved with math? A lot of mathematicians like to say, I'm good at math because I'm a genius. I think you're good at math because you can sit at home and think about it all day. Right? Math is like exercise. Daily commitment. All right, what about this? Negative 1 times negative 1? So we've got a scalar column vector, row vector, times scalar column vector, row vector. Are any of those things commutative? Can I bring out any of those? The scalars I can bring out. So I can bring out the scalar in front. Negative 1 times negative 1? Positive 1. How about these? Can I just flip those around? How do you know that? Because I messed up on the exam on that problem. It's a good mistake, right? That's a real, yeah, you don't say it in public though. You got to make people be like, because I was born like that. Right? So I can't actually flip those things around. Then they'll be like, oh, you're a real mathematician. Okay? But I can bring that thing out, and then right now these are associated. Anybody recognize something happening right there? What is E1? Yeah, it's like 1, 0, 0, 0, 0, 0, but then I transpose it. So now I've got a 1 followed by all zeros. What is E2? 0, 1, 0, 0, 0, 0. So now I've got a 1 followed by all zeros as a row vector, and a 0, 1 followed by all zeros as a column vector, and I multiply them together. What do I get? So that's 0, which means that I have a 0 times E3 times E1 transpose. That's a matrix, right? But the entire matrix is scaled by 0. So what happens to that entire factor? 0. Which means what about those two products? Look at the sum. What's left on the sum? So let's go ahead and take a look at this. So this implies that S31 negative 1, and I cannot wait for you to make a conjecture. A conjecture is just begging to be made here, and I think all of you are going to jump right to it, and then you're going to be like, oh my god, that's not that hard. And then I'll be like, yeah, you're right. If we were like 50 years older, we would be like world famous right now. No joke. I don't know, like Ali Wong famous? We might be like, I don't know. She's pretty famous, right?
Haven't we done this one before?
We did something very similar to it. Now right now you're figuring out why I had you do that. Some people are like, why don't you always focus on the entry by entry? But the problem with entry by entry is it limits you to a very, very specific set. This allows you to do the general case quite quickly, in fact. What does this one look like? Okay, what about this one? Basically all zeros except in the third row, first column I have a. And what about that one? Okay, so what's this matrix right there? I forgot to use head and shoulders, I think. Any conjectures? Well, forget about conjectures. Any observations? What is this matrix? So let me just show you what this looked like. Looks like what? They got married. They got married. Usually the marriage night's not on public, right? But I suppose, yeah. But it's not always intuitive, right? Because matrix multiplication is kind of a nasty thing. I mean, it's actually quite beautiful, but there's a lot going on there, right? There's a ton going on in matrix multiplication, and yet, what happens? Yeah, what happened was this element got picked off in the exact location, and this one did too.